Right. Good afternoon, everyone, and thank you for joining us for this last session of our IPCon on day 2. I just want to shout out to Grandstream who have sponsored this entire IPCon, and this is why we're able to do IPCon online this year. And also, I just want to say I am joined by Boris Maisel. He is the Associate Vice President of Business Development at Siklu, and also by Denny Van Simon, who is a Siklu Regional Sales Director in Africa. They will be presenting this session. So without further ado, before we go on, please let me know if you can hear us clearly, if you can see the screen. There's a little chat box to the right-hand side of the screen. If you could just give us a yes or a no. Okay, awesome. Looks like we're good to go. All right, Boris, I'll hand over to you.
Okay, thank you for the introduction. Nice to meet you. Thank you for the opportunity to present during the conference. My name is Boris Maisel. I'm based out of California and leading the business development in the United States and covering big accounts, big telcos here. And as you know, probably this is something that is happening across the world. The rural opportunities for connectivity becoming more and more important to provide reliable and affordable gigabit connections to those rural use cases, rural communities. This is something that is happening all around the globe, and I'll share some of our success stories, some of our experience about how to do that. You are welcome to ask questions. You can post it and we'll handle it at the end of the session. So in today's reality, the worst thing you can do is to turn down a customer that is asking to be connected. You can claim that it will take you too long to connect his office, his building, his premise. You can say, well, it takes me too expensive. I cannot provide the bandwidth because in the competition and with the technology that is available today, there will be someone else that will take advantage of different technologies, of different communication technologies that are available out there, and will take over this opportunity. So instead, we are going to talk today about millimeter wave. There is going to be another tool in your connectivity toolkit which will enable you to deliver gigabit capacity, and we are talking about gigabits up to 10 gigabit per second, to deploy it faster with less people, because the installation is going to be, as we will show you, the installation is going to be very simple. And at the end of the day, you'll be able to make more money because you'll be able to attract more customers. You'll be able to compete better with the incumbents, providing better service. And because the equipment is not expensive, because the installation is simple, because it takes less time and less people to install those radios, you'll be able to make more money. So the agenda for this webinar is to give you guys a brief introduction about millimeter wave, about some specifics in the regulation in South Africa, to go over solution building blocks that Siklu provides. And as you'll see, we tried to come up with the solution concept. And it's not just a single radio, it's a toolkit that enables you a lot of flexibility and target a lot of use cases. And as we've mentioned at the beginning, to make money in all of them to be pro. So all the use cases that we are going to cover today, these are something that are implemented. We are going to review the topology, and also success stories of different customers. How how did they do that? Why they did that, etc. And we'll wrap up with a couple of words about Siklu and Q&A session. So first of all, the basic technology, the frequency that we are talking, the first layer is millimeter wave. So what's so special about millimeter wave and why it is so helpful for you to achieve those goals that we presented at the beginning? So this is the spectrum that we are talking about, V-band, which is the 60 gigahertz, and E-band, which is the 70, 80 gigahertz. As you can see here in the simple diagram, it is pretty easy here that the spectrum that is available in those bands, actually we have a huge amount of the spectrum, and it is more than all other bands put together. It means on the practical side that the more spectrum you have, the more capacity you can deliver. In South Africa, E-band is unlicensed, and it is from 57 gigahertz up to 66 gigahertz, which is 9 gigahertz of unlicensed spectrum, which is more than all other bands put together, which is more than licensed and unlicensed bands put together. The 7080 is lightly licensed. The cost is per link, $10 per year, which is really negligible comparing to other alternatives, to other traditional microwave bands. And it is, you get all the protection like in traditional microwave. So the first property is massive amount of spectrum that enables to deliver high capacity. We talked today about commercially available systems that are capable of delivering 10 gigabit per second whole duplex. It means 10 gig up and 10 gig down. And we are working on a solution that will go even further in terms of capacity. The second property of those bands is that they virtually immune to interference. As you go up in the frequency, the antenna becomes more directional. And here, this is a simple illustration of E-band radio, which has a antenna beam width of less than 1 degree compared to 5.8 gigahertz radio, which has a directional antenna at the same size. Its beam width is close to 15 degrees. It means that if the beam width of the E-band radio is at least 15 times more directional comparing to other lower frequencies. It means that instead of spreading energy all across those locations, you are laser beam focused on the location that you'd like to serve. This is on the transmission side. On the receiver side happens the same. Instead of collecting energy from all other interferers, you are just focused on the radio on the location that you'd like to connect. So this is first property that has to do with immunity to interference. Now, the fact that you have a lot of spectrum, it also provides you another kind of option or another point to reduce the interference, because you have a lot of spectrum available. It means that you have many non-overlapping channels, and you can have a very flexible network in terms of radio planning. You can choose channels. For example, it is very important in unlicensed bands. You can choose channels that are free and are not interfering with others. Now, those channels are wide, and it means that in order to achieve gigabit capacity, you still can utilize low modulation scheme, and the lower the modulation scheme is, more immune it is to CPI, to interference, and this is another contribution to the immunity to interference. So basically, this technology is physically, because of its physical properties, it is virtually immune to interference. Now, a lot of things improve when you go up in the frequency. Another thing is when you have faster communication, when you deliver gigabit capacity, it lowers the latency. So in our systems, the latency is anywhere from 50 microseconds to 1 millisecond in point-to-multipoint products. And together, it actually forms a very advanced communication system that can serve many locations and many use cases. So to sum up, the physical characteristics of those millimeter wave frequencies. First, these are unlicensed or lightly licensed. Second, it can provide gigabit capacity in a very easy and cost-effective form. Third, it is immune to interference. And immunity to interference, it means that once the network is deployed, no matter how dense it becomes, it is the line of sight technology. We'll talk about that. And if this network is engineered correctly, it doesn't matter how dense it becomes, how many incumbents are there, and how many links are installed. You'll get your gigabit delivered to the customer no matter what. Okay, so it contributes to reliability and to the future proof of this technology and the network future. Now, building blocks in terms of the radio, what we provide today. We have 3 product lines. The last one is not available yet in South Africa because of the regulation. So I'll focus on the point-to-point radio. On the left-hand side, you can see this is a point-to-point event radio. This one is capable of providing up to 10 gigabit per second full duplex. We have different flavors. We have 1 gig, we have 2 gig, we have 10 gig, and in 10 gig we have different licenses. So you can pay as you go. You can deploy a network that delivers 2 gig, and then when you see an increased demand in capacity without truck rolls, you can upgrade the capacity to 5 gig, and if you see even more need in bandwidth, you can upgrade it to 10 gig, everything without leaving that. This radio is good up to, as a standalone solution, we have 1-foot antenna and we have 2-feet antennas. As a standalone solution, it is good up to 3.5 kilometers. And with extended MEM technology, which we'll review shortly, it is good up to 10 kilometers. And even we have a customer that deployed it in 12, in a little bit more than 12 kilometers in South Africa. So this is point-to-point radio. Because of the form factor, it usually goes on rooftops of the buildings. It usually goes onto towers. And this is kind of the pipe that feeds the network. The second radio, which is here in the middle, this is the point-to-point event radio. This is a small form factor. 15 by 15 centimeters. It is an integrated box. As you can see here, there are 3 Ethernet ports, and it enables to support many different topologies. You can connect a camera, you can connect a small cell, you can daisy chain another radio. There is the PoE in and 2 PoE out, and the embedded switch to handle all the network functions. It supports POS, of course, and a lot of math-related functions, QMQ, CFM, OEM, etc. This technology can be deployed at the street level. So this is another kind of enables another use case and provides flexibility. This is the building blocks that when they combine together, as we'll show in the use cases in the next slide, they create a very powerful solution. So this one goes at the street level. It can be deployed at the street furniture, at building facades. It can be deployed on poles. And the prime use case of this technology is really connecting access devices like cameras, Wi-Fi, and providing kind of another layer in the topology that we built. We have another product line that unfortunately is not available in South Africa. These are point-to-point, point-to-multipoint, and the upcoming telegraph. We'll not focus on that. Once it is open, we'll of course inform you and work with our channel to provide you this solution in general availability. So we reviewed the millimeter wave, which is the background technology. We reviewed the building blocks that enable to build different network topologies. Now let's review how it is used in the real world. Basically, I would say that we have those 4 buckets for gigabit fixed wireless access. The first one is business broadband, connecting commercial buildings. Sorry, the distances here in miles, but for the business broadband, as a standalone solution, as I've mentioned, it is good up to 3.5 kilometers. With extend-demand technology, it is we can provide up to 10 gigabit per second full duplex at the distances up to 10 kilometers. We serve also our equipment is serving residential broadband. It has to do with multiple dwelling units, with the single-family homes. We have many projects with affordable housing in the United States, in UK. We have the solution enables to serve applications for smart city, and it has to do with the CCTV connectivity, with the Wi-Fi backhaul, with connectivity of municipal buildings or city buildings, and also backhaul like cellular backhaul, small cell backhaul, fiber backup, etc. So this is for what we call fixed wireless access. Now there is another vertical that the tower equipment is being used at, and we call it enterprise connectivity. And we have hundreds of different projects that are not related directly to broadband, but more to kind of private network. We have projects in power plants, we have projects in seaports and airports, we have projects in retail. In South Africa, we have projects in mines. We have projects in healthcare, connecting campus buildings or providing backup to the existing fiber, campuses, schools, travel and hospitality. We'll show you some of the examples. So the first use case, we call it the main street connectivity, and it enables to connect locations in rural communities in the following topology. Usually, in all our deployments, we start with fiber. So though we are a wireless company, we are not competing with fiber. We are extending fiber. Fiber, as we know, struggles when it gets to becoming a cost-effective solution and also speed of deployment. You don't want to let your customer wait until the fiber is ready to be deployed. No one today is, I'm talking from the customer's perspective, no one is willing to wait weeks to be connected to the internet or to upgrade his service. So fiber is good when it is available. When it is not available, it is costly and time-consuming to deploy. And this is where our technology, where millimeter wave comes into the game, and we extend this fiber. So usually the fiber is available at the tower. The tower is placed outside of those small towns, small rural locations, and then the E-band radio is used to extend the connection from the fiber to the what we call the downtown area, or it can be industrial park, it can be campus. The same technology, it's the same topology, the same building blocks will work there as well. So this fiber is extended using E-band, that can provide up to 10 gigabits per second. And then from this location, it can be served using V-band to serve other smaller locations. Okay, this is how it is done. This is a real use case, a real customer, Jade Communications here in the United States. He has a tower with fiber. You can see here, this is big tower outside of the town that he runs. And he uses E-band to extend the fiber from the main tower to small tower in the downtown area. Then he uses point to multipoint, but point to point V-band can be used there as well to serve individual customers. Once this portion is deployed, he has all downtown area covered. In this way, he connects anchor institutions, which are municipal buildings. He connected courthouse. He connected um, fire station, police station, and other municipal buildings, and also small businesses, coffee shops, law firms, etc. Okay, so this is something that enables to extend the fiber outside of the town and bring it in. Just to give you a sense of what does it mean in terms of distances. So we are talking about standalone technology, standalone solution event, which is built up to 3.5 kilometers, and this is Johannesburg. Okay, so this circle, the yellow one, is 3.5 kilometers radius. It means that a tower that has line of sight within this range can connect to any location, to any other location that it has line of sight. Okay, so this is the distance of event radius. So within this circle, you can deliver 10 kilometers as a standalone solution. Now imagine what you can do with 10 kilometers. Okay, with extended amount. All right, and the second building block, as we mentioned, this is the V-band. This is point to point. This is 1 kilometer coverage. Okay, so pretty much all downtown area is covered with this radio, right? So once it is deployed on tall buildings that has line of sight to other locations, there is not a lot of vegetation in those places. You can pretty much cover every block in the city. It goes to buildings, but it can serve also pole locations for smart city applications. So those two building blocks, E-band and V-band, provide a very flexible solution. Okay, and there are some examples from Nigeria. As you can see, the installation is very simple. It is integrated unit with Ethernet cable, goes on a single pole. This is the 10 gigabit on the right hand side, 10 gigabit. The same form factor is for 1 gigabit solution. And this 60 centimeter dish can provide connectivity for pretty much for the whole town over there, right? 10 gigabit is more than enough to serve the small town. Next series of use cases are related to enterprise network. Enterprise network, and it has to do with the same building blocks, the same topology can be utilized to serve those locations as well. I would say that the prime use case in those enterprise networks is surveillance and fiber redundancy. In some locations, in some places, there is fiber available, but this fiber is not really reliable. It can be aerial fiber, it can be buried fiber, but in some locations it is ripped off oftenly, and when the fiber is not available, actually the whole facility becomes unavailable, becomes useless. So in many cases, we see that our links are deployed as kind of insurance to ensure that there is operation, even if there is fiber, just in the case when the fiber is not available. So this is one use case. The other use case is surveillance. A lot of automation is taking place in those areas, and autonomous cranes, some autonomous mines, um, uh, locations, warehouses that should be monitored. So high-end surveillance systems usually deployed that require bandwidth that is not available in any other technology besides millimeter wave. Usually, the video data from those surveillance networks is fed into AI and machine learning systems to identify objects, to identify different actions, and it requires a very high quality video signal. And this can be delivered with fiber or with millimeter wave. No other technology, because of interference and because of spectrum availability, is not capable of doing so. Therefore, you'll not pull fiber just to connect camera. It's not cost efficient, and it takes a lot of time. And many of those facilities use our equipment to do so. Okay, so this picture is taken from the port of Long Beach. This is the second busiest port in the United States. We have close to 100 devices there, and as you can see, once again, it is a combination of E-band radio and V-band radio. Okay, it gives the flexibility in terms of capacity, in terms of places that you can deploy. Another example is airports. The same thing to connect distant locations or work areas in those airports. This is the last one from John Glenn International Airport in Ohio. Also, several systems were deployed to connect work areas and provide backhaul to Wi-Fi net. Another use case is the critical infrastructure, and it has to do usually with perimeter security. So usually the cameras are deployed across the perimeter of those locations. It can be a power plant, it can be a distribution site, it can be a large factory, and then those locations are connected with our radios, usually aggregated to the main location, to the main node. And here are some examples of the installation we have on one nuclear power plant. You can see a lot of radios co-located. These are high-end cameras. Each camera requires somewhere between 50 to 120 megabits per second. And once again, there is no other wireless technologies that can handle it besides millimeter wave. And also, you can see that there are many radios co-located. We implemented here ring topology without single point of failure. And all those radios are located at the same location, operating without interference. So this is just to illustrate the physical kind of characteristic that we've talked about this frequency band. And this is on the liquidation gas liquidation facility. You can see that the network goes across the perimeter, and there are some aggregation points at the middle of the facility, and it is implemented in ring, no single point of failure. So if one of the radios disconnects from some reason, all network elements will still operate. Okay. Now we talked about distances, and we stated that this is a standalone solution. This technology is capable of providing 3.5, 3.5 kilometers, but using extend-MM, it can be extended. So how does it work? First, let's understand the meaning of availability. Without rain, this technology can go to very long distances beyond 10 kilometers. But when you plan your network, the main limiting factor when you deal with millimeter wave is rain. So you need to take into account rain attenuation. And this is what limits the distance. Okay, so if you want that this 10 gigabit link will be available for 99.99% of the year, you'll need to take into account rain that corresponds to this availability. And it means that 99.49 of availability, it translates into 50 minutes of downtime. But what if you want to compromise on the capacity, but you still want that the link will be connected? And this is where we developed the extended technology. And this is actually a combination of two frequency bands. So you get the benefit of millimeter wave frequency of E-band that can deliver 10 gigabit speed, and it will be available during 99% of the time. It means 362 days a year aggregated. And during those 3.5 days, that there will be heavy weather condition, heavy rain, it will lose connectivity, but then the backup solution that will operate in lower frequency band that is not subject to rain attenuation will kick in and will keep the connection up. Okay? So 99% of the time, the link will be up at 10 gigabit per second. 1% of the time, the link will provide 100, 200 megabits per second, which is delivered by low frequency range. Now, all the logic, all the brains of the switching is sitting inside our radio. You don't need to add additional networking devices, additional switches. Once the E-band senses that the link degrades and you set up this threshold from EMS, from CLI, from web interface, then the E-band radio will switch automatically the connection to the backup radio, and the connection will be maintained. So what we've seen is that customers, they don't care about those drops in capacity. What they really notice is that when the connection disconnects, and this is the solution. So this is something that enables to extend more than double the capacity of E-band radio, deliver 10 gigabit over distances of 10 kilometers at 99% availability, and still maintain the link during the remaining 1%. So it is always on system that 99% of the time delivers 10 gigabit per second. Now we have also a dual band antenna that doesn't occupy additional space on rooftop or tower. This antenna supports E-band and sub-6 5.8 gigahertz. So with a single footprint, you can connect our E-band radio and a backup 5.8 gigahertz radio in a single antenna. Okay, this is a very cost-effective solution, very easy to operate, and we interoperate with the leading vendors in the sub-6 space. Okay, and here are some examples. We have a customer in South Africa that deployed 10 gig radio at 10.4 kilometers, and we have someone else who deployed this radio in 12 kilometers. Last use case that we are going to talk about today is DSLAM Backhaul. So DSLAM uses a twisted pair. Twisted pairs are pretty common in many countries, and this is what reaches customers. The problem with most of the deployments today is that there is not enough capacity at the aggregation point. And those aggregation points are pretty much they are distant from customer premises, and the higher the distance is, you can see here uh, an exponential drop in the capacity. The longer the distance is, the less capacity you get. Okay, so what we propose is extend those, bring those cabinets, bring those DSLAM cabinets closer to customer premises, and bring more capacity to those locations, and then you can deliver hundreds of megabits to those customers without truck roll. So just upgrading the DSLAM equipment to more advanced digital technology, using, instead of changing fiber to those locations, extend the existing fiber with millimeter wave radios and bring this 10 gigabit connection to the DSLAM aggregation point, and use the existing infrastructure to upgrade the service. So instead of providing 5 megabits per second using the existing network, you can upgrade it to 100 meg without backhaul. You just need to upgrade the DSLAM cabinet and send new modems to those residents. So this is kind of a very easy way to upgrade the existing twisted pair network. All right, so these are, we have a lot of other use cases, and maybe we'll do another webinar. Maybe we'll talk just a little bit more about point-to-multipoint system. Just to summarize a couple of words about Siklu. We are in the market. The company was established in 2008. We are market leader in this space, in the millimeter wave, and as you probably know, E-band technology, E-band spectrum is lightly licensed in the UK and United States as well, and the regulator keeps the record of all the links that are registered, and this record is publicly available. So in FCC, if you look at the numbers, we have about 2/3 of all the links that are registered in the United States in millimeter wave are Siklu. It means 2 out of 3 radios that are deployed are made by Siklu, and the same is within the United Kingdom, within the UK. And this is not market research. This is not an analyst report. This is the actual data from the regulator. Okay, you can see here. This is the snapshot from United States where those things are deployed. So it's publicly available data, pretty much everywhere. All right, we have deployments in Alaska. We have deployments in the south. We have deployments in the central part of the United States. It means that this equipment is reliable and can work in any weather and environment conditions. We have more than 100,000 units deployed worldwide, and more than 300 cities that use our technology for smart city applications. These are some of the selected customers. We have AT&T, which is large carrier in United States, Vodafone, fiber carriers like CenturyLink, SoftBank in Japan, another fiber carrier in the United States, KDDI, Telecom. I mean, all around the globe, big service providers, small service providers, Wi-Fi. Boingo is they provide Wi-Fi connectivity and the military-based connectivity in the United States, ports, police departments, you name it. Okay, and this is because of the flexibility of the solution, and those building blocks, when they come together with our tools that enable simple planning, simple calculation, simple performance calculation, they become a very powerful and very robust solution. And there is a problem you can reach out to Myro to get some more details. We have a very attractive promo on our leading solutions, which are 2500. This is the 2 gig radio and the 8010, which is 10 gig radio. Here are the prices. The promo is available. We have it with the 2 footer, and we have with the dual band solution, 2 foot that supports the dual band. Please reach out to Myro to get more details and take advantage of this technology. As a summary, millimeter wave is superior to any other wireless technology. So if you compare it with the traditional microwave, with the low frequency radio, this is the capacity that you can deliver here is an order of magnitude more than in any other wireless technology. So it means that you don't need to upgrade your network every every year and a half because the capacity grows. It gives you the peace of mind that the network that you've deployed today will serve you in the future. The fast deployment cycle, it means you need less people. The coordination is simple. You get the license in E-band or you use unlicensed band, V-band, and you have a customer that needs a connection. You go there and you get them connected, and it means that you get a faster revenue cycle and lower funding. As I've mentioned, we provide a complete solution. We have planning, we have some business tools to opportunity assessment. We have the hardware, the radios, and we have the implementation capabilities, training, and partners to support you. Take advantage of this technology, deliver gigabit speeds in an effective way, and take advantage of the promo. So this is it on my side. I think we have some time left for the questions.
Great, thank you very much, Boris. Yes, we do have some time for questions. So if any of you have any questions, please do pop it through into the chat box. While we wait, I just want to quickly share a link with you. Tomorrow we'll be having a more detailed deep dive Siklu sessions. We'll be having 2 of them. We will be looking at the smart wall features from Siklu, and also the second session will be a bit more detail into the millimeter wave installation. So for any of you who are interested, they're about a 1 hour slot. If you're interested, please follow the link and register for a spot, and then we'll see you tomorrow. And if you have any questions about anything if you would like more information on the equipment or anything from Myro's side, you can email me if you want interested in testing out the equipment. That's something Myro does offer. That would allow you to take the equipment, test it out, check whether it would work in the environment in which you want to put it, and if it works, you keep it. If it doesn't, you return it back. Of course, there are terms and conditions, but if you're interested in taking advantage of these awesome promos that are running currently, you can contact me, and I will give you as much info as possible. Same with Danny, he's very helpful, and he's very quick to respond to your emails, so please do reach out to us if you have any questions. Other than that, I thank you for your time, and I hope most of you join our sessions tomorrow. Thank you, Boris. Anything else from your side?
No. I will share the slides, and they will be available.
Great, thank you. I think you were very straightforward with the presentation, which is why there's not a lot of questions. I think it was pretty clear. So yeah, that's a good thing. Thank you very much once again. And yeah, I think we can exit.